Okay. So let's use page 107 to do everything that we can do with quadratics. Okay? Let's do a quadratic formula, even though we don't need to for these ones. Let's do a complete the square. Let's do a factor. And then I'll let you guys do the last ones, however method you choose. Okay? Everyone cool with that? All right, so let's look at this first one. It says I want to graph it. So we have, how many options did I just give you? We could put it into vertex form using complete the square. We could put it into vertex form using this. Where is it? The b, negative b over 2a. We could factor it and find the roots, if it factors. And once we have the roots, we can find the vertex, right? Or we can quadratic formula it. Everybody cool? All right, so let's look at this. Let's do this one with factoring. So we're going to do this one factoring. So look at that. Can it be factored? Are there factors of negative 10 that add to positive 3? 5 and 2, right? Which one's negative? Negative 5 or negative 2? Pardon me? Negative 2. Right. So we're going to have x plus 5, x minus 2 equals y. Yes? And if I want to graph that, then I need the roots, correct? And the roots exist when y equals what? 0. So if y equals 0, then I either have x plus 5 equals 0 or x minus 2 equals 0. So what are my roots? Right. Negative 5, and positive 2. Yeah? Now, what do I know about the vertex of every single parabola? Where does it live? Right. The axis of symmetry is right in the middle, yes? And I can always find the axis of symmetry morning. The axis of symmetry is in the middle. And I can find the middle with x1 plus x2 divided by 2. So what is that? Negative 5 plus 2 divided by 2, yes? Which is what? Pardon me? 1.5. Right? Does that make sense? Yeah. That makes sense. Yes? Pardon me? Negative what? Does that make more sense? Yes. Why? Because negative 5 plus 2, it's not negative 5 plus 2. The question I'm asking, this right here, P plus Q over 2, right? Okay, so what is P here? Okay, let's do this again. Equals negative 5 plus 2 over over 2, right? Which is negative 1.5. Now, when you do that, that can't possibly make sense, can it? I'm asking you, does that make sense? You've done some work. Does it make sense? Why? If I go down 2 and another 1.5, that's 3.5, right? And if I go this way, from 5 to 1.5, that's 3.5. So it makes sense, yes? The reason I'm stressing this is because negative numbers mess with your guys' heads. All right? You have, just because there's a formula, if you're not using it right and it doesn't make sense, should you use your result? That's what I'm trying to get at. You have to make sure it makes sense. And negative 1.5 makes sense, yes? Everyone's happy with that? Okay. So is that an X or a Y value? X value. So what can I do with that? Plug it into the equation. So I can take that and go negative 1.5 plus 5 and negative 1.5 minus 2 to get my Y value. What is it? Cool. Hey! Awesome. So it's going to be able to happen? Sweet. I wasn't sure. Are you doing it?
I'm helping.
Nice. Remember, math's your favorite subject. And my kid's riding that car.
Yes.
So be careful.
I'll keep that in mind.
There you go. Thanks. All right. Sorry, guys. Where was I? Oh, yeah, here. What was it called? I'm sorry. That negative 12.25 or something? So now can I graph it? Yep. So the axis of symmetry we knew was at negative 1.5, yes? And then I put my other dot down here at negative 12.25. And there's my graph. So everybody's comfy with factoring? Okay, what do you want to do for the next one? We just did factoring. What should we do here? Quadratic formula, complete the square, or negative b over 2a and find the x-intercept, or the x-vertex. Find the x-vertex. Okay. So that means I need to know a, b, and I only need them for the x-vertex, don't I? So what is the x-vertex? V of x equals negative b over 2a, yes? So what is it? 1 over 4. Everybody cool with that? Yeah? Okay. So if that is my vertex, it's an x value. What do I do with that number to find my vy? Plug it in. 2 times 1/2 squared minus 1/2 minus 3. What's 1/2 squared? Try again. 1/4. What's 1/4 times 2? What's 1/4 times 2? You can do it. Bring it home. 1/2. So that's 1/2 minus 1/2 minus 3. So what's the y value? Negative 3. So what's the vertex? Yo.
Isn't it the 104, not 102?
What's 1/2 squared?
Yeah, but isn't that
Just what's 1/2 squared? 1/4. What's 1/4 times 2? 1/2. What is 1/2 minus 1/2? And what is 0 minus 3? Okay, so I think I'm right. You tell me where you think I'm wrong. I got the Vx as 1/4. Right. Okay. Why did I do that? Why did you guys let me do that? Jeez. The Vx is 1/4 because it's 2 times 2. So what is this? 1/4 squared. What's 1/4 squared? That's better. 1/16 times 2? 1/8. So that's 1/8 minus 1/4, yeah? So what's 1/8 minus 1/4 minus 3? Sorry, guys. It's Friday. Whew. Feel like a dummy. What's 1/8 minus 1/4 minus 3? Pardon me? 8/3. 1/8 minus 2/8 is negative 1/8. Negative. No. Negative 25/8. Which is negative 3 and 1/8. So now, do I know the vertex? What is it? 1/4. And then where? So it's 1/4 and negative 3 and 1/8. Yes? Now, I only want a sketch of the graph, right? Where else can I put a dot on there? It's yucky because it's got fractions. But there's one more piece of knowledge we know right here. What can this form tell us? We have a list of the things it can tell us. What can that form tell us? Y-intercept. What is it, Antonio? -3. So that means there's a y-intercept right there at -3, yes? Which is 0, -3, correct? Right? Which is 1/4 away from here, yeah? I tell you need to have 3 points for a parabola, right? We know that there's got to be a point over here at -3, yes? Right? And it's got to be 1/4 this way, correct? So what is that point right there? What's 1/4 to the right of 1/4? 1/2, yeah? So this is 1/2 -3. My numbers are disappearing today. Numbers are still disappearing today. There we go. And now, can I graph it? Sweet. Okay, now what? What do you want to do for this guy? We've done factoring. We've done -b/2a. So what's left? Complete the square and quadratic formula. So why is this not a great one for complete the square? Why don't we like this one for complete the square? Because half of 7 gets us fractions. That makes us all cry, right? So this would be not a great one for fractions or for complete the square. Now please notice all of these are factorable. We could have factored them all. I'm using this as warm-up for everything, right? So we could factor this, but let's pretend we can't. So what's left for us? Quadratic formula, which, if you don't remember it, as always, I will supply it to you. It is. Does anybody have it memorized? Negative b plus or minus the root of b squared minus 4ac over 2a. Look at you guys! Holy! I don't know why numbers are disappearing, but you know what it is. So, you guys start working on that one while I close this program down in hopes that that stops the numbers from disappearing. Minus. All right, so A, B, C. What is it? 7 plus or minus. Over 7 plus or minus. What's negative 4 times negative 8? Positive 32. What's 49 minus 32? Right? Everybody happy with that? Everybody happy with that? What? Good question. That's why I'm glad we did this one here. That's why I leaned you guys into that. Is this one going to work out? Ow. Look closely at it, guys. Are you happy with this? Why not, Antonio? Isn't that a negative? So what happens here? So what happens? Is it 49 minus? So what is it? 81, right? It's plus. Now, are you happy? Now, Jazkira, in this question, are you going to finish it off? Why? Because 81 has a square root, so we'd finish it. But if we didn't have a perfect square root there, how would we leave it? You would leave it like this, unless you needed the value, correct? Then you would find me a decimal. One is exact, one is approximate. Which one would you use in physics? Right. Or if I needed a value, right? Like, when does the ball hit the ground? Well, the ball hits the ground at 7 plus the square root of 79 over 2, Mr. Myers. See what I mean? What is the root of 81? 9. So it's 7 plus 9, which is 16 over 2, which is 8, or 7 minus 9, which is negative 2 over 2, which is negative 1. Now, that's the roots, right? So can I graph it? What's halfway between negative 1 and 8? What? 3.5. 3.5. There we go. So we know that this is 3.5. What do we do with that 3.5 to find my vertex? Where does it go? Into there, right? And could you do that in your head? You can do 3.5 squared in your head? I think it's 17.25, but I'm not sure. No, 12.25. No, 12.25. That's my guess. 12.25? 12.25 minus 24.5. Yeah? Minus 8. You guys have to figure that out. I can't do that in my head. Not on a Friday morning. What is? The same way we always find it. We take the 3.5 and we put it in for x.
No, but like, how do you
Well, that's the halfway between thing, right? What's negative 1 plus 8? Right? Okay, so what's the answer? Negative 20.25. So I put a dot right there. I label it. Does it really matter in a sketch where I put it if I label it? No. Do I have 3 points? Can I connect them? And finally, Max's favorite. I don't know if it's his favorite, but he always seems to do complete the square. Complete the square here. Y minus 15 equals x squared minus 8x plus what? 16. How much should I add to the right side? So how much do I add to the left side? 16 to get y plus 1 equals x minus 4 squared. Y equals x minus 4 squared minus 1. Can I graph that? What's the vertex? Positive 4, negative 1, negative 1. Any stretch? So does it follow the pattern? How? Over 1, up 1, right? So I'm going to be at 5, 0, and 3, 0. And there's my 3 points. And that's everything we've done all on one page. This is a real good page. Where did it go? What did I just do? Page 107 is a real good page for studying because it's got everything on it. Right? It's got factoring. It's got complete the square. It's got quadratic formula. It's got negative b over 2a. It's got substituting back in. It's got the y-intercept. Right? It's got everything. Which also makes it the perfect page for a warm-up for a quiz, which we're going to do in a few minutes. Now, I did say I wanted to give you guys a little bit of practice on your own. So, because we have a quiz coming up, there are 2 more questions. Okay? You have 4 methods. Do I care which one you use on any one? Will all 4 of them work? Right? They will all work. The only one that doesn't always work is factoring. Right? Now, I'm going to tell you right now, you could factor both of these. Okay? You could. But I wouldn't recommend factoring both so you can get practice in one of the others. Do you understand what I'm saying? And you can work with your neighbor. It's not a quiz. Try it out. Go. And guys, the quiz is 9 multiple choice questions and 3 fill in the blank. How long do you feel you will need? Will 20 minutes be enough for that? How about 25? We'll go at 9:05 with the quiz. That's in half an hour. That gives you enough time to practice these 2, and then we'll do the next 2 very hard questions together. And that should take us right to 9:05. Then you write your quiz. Then you got no homework for the weekend. Sound good to all?
Yes.
All right, go. Move the what, huh? Oh. But you have this right in your book in front of you. Okay. Yes. We need to use them today at all? Oh yeah, you can use them if you want. You want me to go get them? Does anybody else want a graphing calculator? Son of a mother, let's go. Okay, I'll be right back. All right, the huge. You can trade one in. Now, guys, please remember, I do expect you to be able to do all of this with algebra, right? And or the graphing calculator. But the important word there was and, right? Make sure you can do everything we're doing here as well as work the graphing calculator. Everybody cool? Right? Because the graphing calculator isn't going to give you exact answers, is it? Excuse me. Ladies and gentlemen, I'm sorry to interrupt. I'm just going to do these two. I'm going to turn the screen off. I'm going to do them in whatever method I choose. And then if you've done yours right, we should have the same answer, correct? I'm going to keep recording it for the methods I choose. All right? And then you can check it later if you want to see the actual work through. All right?
First thing you did when you were here. Yeah, bro.
Because you're graphing it wrong.
Because I tried to.
Oh, no. I know what that is. No. I know what that is.
Because I was just trying to do it on here as well. Because I tried on that one, it worked, but on here it didn't work.
There you go. That's fixed. Now your window's screwed up, right?
Yeah, I know how to
So
fix
you know how to fix the window? Okay.
Thank you.
If that happens again, it's because when you go into the y equals screen, look, I'll show you on this old one. If you go into the y equals screen, if you see plot 1, 2, or 3 is highlighted, that's why it's happening. So just move your arrow up to there and hit enter. See, so right now it's highlighted, so now I can't graph that.
Oh, okay.
But if I go up there and I hit enter again, it's not highlighted because that's a different kind of graph.
Okay.
Okay?
Thank you.
Yo.
For this one, if you use the negative b over 2a,
Yeah.
put 2 negative 1 or just 1? Because it's like negative x.
Yep, it would be negative 1.
Okay.
And there. Check your work over. Now remember, chances are I did a different method than you, yes? Because there's 4 methods you could have done, right? And you could have done either of those 4 methods on both questions. So don't look so much at my method. Look at my answers and make sure you got them. If you didn't, ask me now. Tell me the method you used and we'll sort it out. Do you all understand? Okay, let's look at the first one. Was everybody able to graph this fairly well? It's a upward opening parabola. It's got roots at negative 8 and 2, and its vertex is negative 3, negative 25. Could everybody do that? Now, depending on your method, maybe you didn't get the actual roots. Maybe you just got the vertex and went over 1, up 1. In which case you would have points of negative 2, negative 24, and negative 4, negative 24. Maybe you have that. Is that okay? Is that okay? Of course it is. It's the same graph, isn't it? Is there anybody that would like to ask about the one I did in green? Remember, if you did a different method, just say, hey, Myers, I used quadratic formula. Can you show me how it would have worked?
Can you use the B formula?
The B formula, the vertex?
Yeah.
Yep, no problem. Is that cool? People want to see that?
Yeah.
All right. So I'm going to erase my green. I'm going to erase everything I've done here because all that's recorded. All right. So Luke wants to do Vx equals negative b over 2a, which is negative 6 over 2 times 1, which is negative 3, right? That's what? An x or a y value? X value. So I can put it everywhere I see what? X. So the v of y equals negative 3 squared plus 6 times negative 3 minus 16. Negative 3 squared is what? 9. 6 times negative 3 is what? Negative 18 minus 16, yes? 9 minus 18 is negative 9 minus 16, which is negative 25, giving me my vertex of negative 3, negative 25, right? Once I have that vertex, negative 3, negative 25. Now, you could just go, because there's no a value, right? You could just go 1, 1, 2, 4. But here's what I did. I saw 25 is a perfect square, yes? Which means if I went up 25, I'd be at 0, right? Since there's no a value, if I go up 25, I must have gone 5 this way, correct? So 5 away from negative 3 is positive 2. So 2, 0. And 5 away from negative 3 is negative 8, 0. Then I got my roots as well as my vertex. Everybody cool? Now, a big mistake you're going to make here, and I don't want to say the person's name, they did all the work right, but then punching that into their calculator, they screwed up and got a weird number. Was there a need for a calculator there? If you wrote it out, it made perfect sense, right? But putting it into your calculator, if you put a bracket in the wrong spot or you forget a bracket or something, you're going to get a crazy answer. And you guys have been so trained to believe your calculator that you're going to write down a bad answer and try to make it work. Now, two people made a mistake on these calculating, and then they realized that can't possibly be right, and they went back and found their mistakes. That's very important. Okay, when you realize that you can't possibly have the right answer showing on your calculator, you have to recognize that you made a mistake somewhere. Okay? Everybody cool with that one? Luke?
You say you can also do up 1 over 1, right?
Yeah? So up 1 and over 1 would have been over to -4, -24, and -5, -24.
Okay.
And then I'd be just as happy. Because all I'm caring about is you get the concept of a parabola, right? Now, I could change the question and say, what are the roots? But I did it. I just wanted it graphed, right? Okay, does anybody want to see this guy? Can I do this one the same way? Did you just ask? Sure. So I'm going to erase my factoring. I'm going to try to erase my factoring. Quality. All right. So again, different color. V of x equals negative b over 2a. So -4 is what? 4. 2, what's a? -1. So that's 4 over -2, which is -2. Yes? Right? So then my Vy becomes negative, what's x? -2 squared minus 4 times what's x? -2 plus 21. What's -2 squared? 4, but there's a negative out in front, so it's -4. What's -4 times -2? Positive 8 and plus 21. -4 plus 8 is positive 4 plus 21 is 25. So my vertex is -2, 25, right? So I go to my vertex, -2, 25, -2, 25. And since it's got a negative a, it's got to go downwards, yes? So I can go over 1, down 1, over 1, down 1. Or I can notice again that 25 is a perfect square, yes? So if I go over 5, I'm going to go down 25, aren't I? So if I go over 5 from -2, I'm going to be out here at positive 3, 0, and -7, 0. And then I have my parabola. Now, if you did the 1 and 1, that's no problem. It's -3, -24, and -1, -24. Cool? Everybody good? All right, I got 904, which gives me enough time to do this question and show you something with the next question. Oh, actually, I guess I don't have time. I said it's quiz time. Okay, these two questions, please notice, I didn't want you to have homework, but I'd really like for you guys to try these. They're tricky, but I want to show you one thing on number 5. This terminology right here, okay? You guys have seen this in grade 10. F of x equals x plus 2, and then I want the f of 7. What do you do with the 7? It goes in everywhere there's an x, right? This is saying you want the f of the g of x. So what does that mean? In f of x, every x gets the g of x. And the g of x is that. So you take this g of x and you put it in right there. Okay? And then try to do this question. Okay? 2 questions for homework. I think that's not too bad. Clear your desks off. If you have a graphing calculator, you are welcome to use it for this because it's multiple choice. But remember, if you're choosing to use a graphing calculator, you need to know how to use it. You don't get to walk up to me and say, Mr. Myers, the graphing calculator is graphing it weird. Okay? These should be hole punched as well. Make sure you put your name on it. And then normally I would get you guys to mark the quizzes, but we don't have time today, so just bring them to me and I'll mark them. And I'll give them back to you and we'll go over them on Monday. Please try to do those 2 questions. When you're done this, you're welcome to get out your big book and work on the 2 questions so you do have no homework for the weekend if you get that far. If you don't, no big deal. I missed you? Well, that's just appalling. I don't know how that could have happened actually. You were up there? You got a lot of nerve. Yes, hit it. What? Yeah. Oh, actually, here, Sarav, I have a ton of scrap paper that I've been trying to use up. Does anybody else want a little scrap paper? I've been trying to use this up, and I can't, because I have the computer now. I just open up a new blank page on the computer and work on there. Oh, and I recorded all of that. So you guys all heard my fun story.